We'll just start our understanding with the basics of GitHub and Agile and Scrum methodology. Because when you look at Azure DevOps portal, if I just browse for Azure DevOps portal, I have multiple repositories. So that's one of my repositories. This is where your code lives. So if you just look at this portal, Azure DevOps portal, if you go to the boards node, you can click on that new work item. You will see a epic which you can create. Then you can create a feature, user story, a test case, issue. All of these are agile terms. Epic, feature, user story, task. These are agile terms. So we need to understand agile because what is being used internally inside the Azure DevOps portal is all agile methodology terms. So that's why agile is something which we will look into. Apart from that, if you just look at the repos, that's where my code lives. And whatever you see in the repos, all of that is built on top of Git. If you look at the pull requests, you can create a pull request and you can give title and stuff and what is your pull request all about. We'll see about all this. But when you look at the term pull request, that's a Git term. When you look at the term branches, that's a Git term. That's why we need to understand what is Git and what is GitHub. Because all of the underlying functionality of repos is all to do with Git and GitHub. So what Microsoft did, they bought GitHub. I don't know how familiar you are with GitHub or Git. So that's your GitHub home page. I have my own sign-in credentials. I can just log into it and stuff. You see how many businesses use it and how many big names are associated with it. All of these are using GitHub. Even Google has GitHub repositories. So it's a very famous repository storing container. So when what Microsoft did, it bought this guy, GitHub, and it integrated GitHub within the repos node. So all of what happens within the repos node, that is with the files, with your commits, pushes, all of this is our GitHub terms, because what they did, they integrated GitHub, which they bought, into the repos node. That's why it's all the same terms what we use. So that's what we will also look at. We'll look at GitHub, we'll look at Agile, then we'll come and start creating user stories and epics, which would be easy for us to understand why we are creating epics, why we are creating features, because that's how Agile works. Once you understand that, then working on these two nodes, once you understand Agile, working on this node, and then GitHub working on this node would be very easy. That's why we'll go there. First understand those terms and understand a little bit of Git, and then we'll come back and start working on the repository. Then we'll keep on moving to pipelines and what is overview, what are dashboards and stuff. We'll explore all of these nodes because all Azure DevOps is about this portal. So everything is in one portal wherein all of your multiple players who are present inside your ecosystem, your project ecosystem will be hitting. So that's what is the plan. So we'll start with this guy, Git and Agile, and a little bit of Visual Studio. I don't know how comfortable you are with Visual Studio. So we'll also look at Visual Studio as well, because that is one thing which we integrate with. So that's one thing which is required because we integrate our repository with Visual Studio. So understanding Visual Studio is also important when you are speaking about Azure DevOps, because Azure is all about Microsoft, and Microsoft proprietary tool is Visual Studio. So that's what we'll just look at as well when we want to speak about repositories and stuff. So let us just look at what Git and GitHub is all about. So we'll just see what Git is. What are GitHub repositories? What does GitHub repository pull request means? And what is GitHub for your organization? We'll look at all different things. So initially, starting with what Git is all about, because all you see here in the repos, all of this is Git. Git is integrated within Azure DevOps portal. That's why it is all the same terminology, what we will look at. So what is Git? Essentially, it's a widely adopted source control system. What is source control system? Whenever you have code, whenever you have code which is present inside your developer machine. Let us say he is software engineer 1 and he needs to store the code. Where will he store the code? He would be having something like source control system. This source control system can be anything. It can be Tortoise, SVN, it can be Azure's repo, it can be TSS, it can get. All of these are different players. Are these the only things? You have multiple source control systems out there. Let this be there. You can see how many source control systems are there. So you have multiple source control systems. It is not like we are limited with anything. There are multiple source control systems we can work with. But if you look at the list, the first one to pop up is Git. That's how famous Git is. So the first thing which people look for when they are working with source control systems, even when I'm searching in Google, the first thing which I'm hitting is Git. That's what this slide also is saying. That's one of the widely adapted source control system. So what do we do with source control systems? Your software engineer 1 stores code inside the source control system, which is Git. When we see when we are saying source control system, it is Git for us. So he stores his code inside Git. It is the same with any of the other SE inside your ecosystem. So all of your software engineers, their local code is pumped into this source control system. What does this do? Source control systems. It stores code. All of your project's code is stored in them. It has all the history of your source code. It maintains different versions and it maintains different releases, because you keep on giving releases to your production environment. So SVC source control system like Git is all about maintaining code, the different versions of code and the history of code. Everything to do with code is all present inside your source control system. So when you have multiple options, one of the very famous options what you have out there is your Git. It's a very widely used source control system. It is distributed. What do you mean by distributed? That's one of the very important things what Git has, which no other source control system, as far as I know, has in the market. What do you mean by distributed? To understand distributed, first we need to understand what is TFS. Whenever I am working with TFS, TFS is also a source control system. When I'm working with TFS, I need to be connected to the internet to actually go ahead and work with TFS. If there is no internet, I would be given an error. So I cannot work with my source control system without internet. It is a live connection. I have to be live connected to my TFS in order to work with it as a software engineer 1, 2, 3. So you need to be having internet connectivity to work with your source control system, because all of your code is centralized. It is present at a centralized repository. So you need to have internet connection to connect to your TFS and then work with your code. When you come to Git, again Git requires internet for sure, because all of your code is in repos, which is present in Azure DevOps portal. But the advantage is, when you are pulling a version of Git and you are getting a particular version of your repository, what do? You get a local repo. Understanding this is important, so just be careful here, because this is why we have multiple commits which we do. I'll come there. So what do you have when you say to Git? When you say to Git, I need a repository of so and so version, it will give you a local repository and it will be in your own laptop or desktop. So in the software engineer's laptop, you will be having a local repository. Whenever you are working with Git, you will be using your local repository, which is present inside your laptop. You will be checking in the code whenever you say commit. These are very common words when you are working with code. Commit. Whenever you commit the code, where do you commit the code? You commit into local repository. You will commit into the local repository. Then what about the global repository? Whenever you want to check into the global repository, you will do a push. That's why you have pushes. How many pushes happened? That's what is the keyword. That's a push. From my local repository, I'll push. When I push, that's when my code which is present in my local repo will go to the global repo. So I do not require a internet connectivity to my Git in order to work with Git. I will be having, as software engineer 1, my own local repository. Same with software engineer 2. He would be having his own local repository. Everyone will be having his own local repository. What is this? Having his own local repository. What do you call this? You call this distributed. It's a distributed architecture, wherein you need not be connected, or it's not centralized. There are two architectures when you are speaking about Git and TFS. It's distributed or centralized. So if I just I'm just seeing one of the basic differences. I'll just pull one slide for this. I don't have it as of now, so I'm just checking it online and then just giving it. So you have this. When you have centralized repository, everyone, all of the laptops are connected to this centralized repository. They have to be connected in order to work. That's not the case with distributed. As I said, each one has his own repository, his own local repository. That's what we represented here, right? His own local repository. So each one, you see that small bubble there. So everyone has his own repository, which he will be working on. And once he is done, he will push. That's the keyword. And when he wants something, he will pull. So these are the keywords which you keep on using. You will push your content to your central repository. You will pull the content from the central repository, but you will be having your own local repository, as what we just said. We will be having our own local repository. So that's one of the key differences when you are working with centralized versus distributed repositories. That is what makes Git so special, because it is distributed. Then you have what is the other advantage, which is free and open source. Whenever your client is looking for anything, if he's looking for any technology which he wants to use, so if he's looking for any technology, the first thing which clients will look for is what is the thing which is free and it's brilliantly performing. So what will we look at? We will look at some technology which is good and free to use and which is very good in its performance. That's what the client is looking for. So what are the things which are free and which are good? You have multiple things. So when he wants to build something on mean stack. What is mean? Mean M is for your MongoDB, which is free and open source. Express, A is Angular, N is Node.js. These are the famous technologies which you can use to build any of the application, which is very performant, and all of these technologies are free. So he will choose something which is free and which is easy to use and which is very performant. That's why you have some technologies like mean going on. Then he will, if he starts thinking about Git, his source control. Git is a very famous source control, which is again free, like your main stack, and which is open source. So that is the things. These are the basic fundamental things which clients look for. That is, they want to use something which is free and which is easy to use. That's why they use Git, and that's why they keep using mean stack kind of technologies and stuff. Git is free and it is open source. What are the advantages of Git? It's pretty fast. So whenever I want to create, if you just yeah, this keeps coming. No issues. Whenever I have in my files, if I just go to my files, this is Angular. Let me just go to some other repository. Yeah. I'll just click on this. I will go to the repos. It is fast. What do I mean by fast? I want to create a new branch. This is a very big branch. You can just see there is so much of code in it. App start in controllers. You have a controller, and in my scripts you have so many scripts. So it's a pretty decently big branch which I'm looking at. So you have multiple views and stuff like that. So we're not looking for understanding what this code is. It's a pretty big branch. I want to clone this branch. I want to create a new branch which is dependent on this master branch, which we just saw. I'll say new branch. I'll say master clone. I'll just use small letters. I'll say create branch. How much time did it take? not even a second. I have two branches now. One is master branch, one is master clone branch. I am pointing to master clone. All of what we saw. How quickly did it replicate? It created a clone for me. How much time it took? I just clicked on it and I got a new branch. If I say another branch, once I create branch, that's what it takes. Now I have three branches: master clone, another branch, and master branch. How much time is it taking to create a branch? Just a split of a second. This is what is required when you're working live. You need to create branches and you need a repository which performs fast. Git is blazingly fast. Whenever I'm clicking on it, all it is taking is my click. So, and it is giving me new branches just within no time. That's what is required. Now you can see that in the branches, I have three branches which I have created. Each of them have their own commit ID and stuff. But you can just see this speed at which these are created. So it's pretty fast. As you start working with Git, you'll understand how fast it is. So it's pretty fast. Then it is disconnected. We have just seen what disconnected is. Every box having its own repo. Every box having its own local repository. It's powerful and easy. There are very little commands which you need to understand. There are a few commands. Any repository will have a few commands. It has commands like push, pull, sync, fetch. You have commands like this. You just have a minimal set of commands which you need to get used to before you start working with Git or Azure DevOps repos, because both are same. So when you are working with Azure DevOps repos or Git, you are essentially looking for a little bit, a very minimal set of commands which you want to work on. We'll look into that. Then you have branching. That is essentially you need to create branches. What we just created. We created branches. We created two other branches dependent on the master branch. So you have branching. So we'll also work on creating branches. How do we merge branches? We'll look at that. To merge branches is where you will raise a pull request. We'll see what pull request is and how to work with pull request and stuff. So we'll look at branches and pull requests. Those are the key things which you need to understand when you're working with Azure DevOps. So we'll look at these things as well. We'll look at whatever we are speaking about now practically. And you can also go ahead and work on this in your local laptops. So one thing, what I want to suggest is to get your environment ready. Have an account in Azure DevOps. It's free. You will not be charged anything. Go ahead and create an account in Azure DevOps. First thing. And log into this portal. You'll just see a blank page. You'll not see anything. You'll just see you can create a repository and stuff like that, minimal options. You'll not see something like a repository already created. You need to create a repository. We'll create it. But first get your account ready so that it is easier for us to work parallelly. So that you can work along with me. When I start creating a repo, you can go ahead and create a repo along with me. Have an account in Azure DevOps. Have Visual Studio installed on your machine. Any version is fine. I have professional version. If you have professional or enterprise, brilliant. If you don't have it, at least install the community edition. This is free. Having a community edition of Visual Studio is free, and having an account inside Azure DevOps, that's also free. Go ahead and have these two as your prerequisite. First have these two today. But after we end our session today, go ahead and create these two and have it handy. Then we'll start working on the remaining things, whatever we are speaking about. But have those two things. Have your Azure DevOps account and as well as Visual Studio. Coming back to our discussion. What is GitHub? We saw what is Git theoretically. We'll also see it practically. What is GitHub? That's your GitHub portal. And what is GitHub is it has multiple repos. So if I say GitHub repos, that's your GitHub repository. That's your repo, which is present inside GitHub. So you have repositories which you can store inside GitHub, and you need to have Git installed on your local machine. That's another thing which I want to say. So another installation which you need to have Git installed. Git. How do I install Git? Just go to Google and install Git. Go to the official gitscm.com, git-scm.com. You'll say Windows. You'll have a download which will start. Go ahead and install your latest Git on your machine. This is something which is used in the backend. So you need to have Git installed. Go to the official website. You'll have multiple websites which you will get when you Google for install Git. Go to the official website. Your gitscm.com, that's the official website. In the downloads, depending upon what your operating system is, Mac or Linux or Windows, just go ahead. If it is a Mac, click on this. If it's Windows, click on this. Linux, click on this. Go ahead and click on that and get the installable and install Git on your local machine. Coming back to our discussion. What is GitHub? GitHub is the place where you store your repositories. We will not use GitHub. We will use Azure DevOps repository, which is again a GitHub repository. It is nothing different. It is the same repository which is used inside GitHub. We'll not use GitHub, we'll use Azure Repo, but both are same. Both are actually helping me host the repository using Git. What am I doing in the backend? I'm using Git commands to store my code inside Azure DevOps repository. That is what is GitHub as well. They both are synonyms now. When you are speaking about GitHub, you are also speaking about Azure DevOps repository, because both are same. Microsoft integrated GitHub within Azure DevOps. So you're just learning two things in one go. So you're just looking at GitHub as well as Azure DevOps. What are the other things which you can do? It is more than just source code management. It can do many things which are other than source code management. We'll look at what are the other things which you can do. And it has both free and paid plans. That is why I'm able to use it with my local account. It's free. Your Azure DevOps as well. It has both free and paid accounts, paid versions. There are a few things which you get extra when you are using the paid version, and whenever you are in a corporate, and corporates have to use the paid version. There are a few limitations. You can use it to a particular set of users. After that, your corporate has to pay for it. So as an individual contributor or a developer, I can use it directly. I can have a Git, a Azure DevOps account free of cost. So you need not worry about any paid things. Whatever we learn it on the free version, and all of the features what you see are all on the free version. And there is no big difference between a free and paid. Your portal will look exactly same. You will not have any extra features. The only thing is more users can use it when it's a paid version, because in a real-time scenario you will be having more users. You will be having multiple software engineers working on your repository, so you'll have more users. That is one of the things which you see when you're working on a repository. You'll have more users using your repo. That's one of the reasons why we have paid versions. Apart from that, all of the features what you see in free version is what is present in the paid version as well. Microsoft wants more and more people to use Azure DevOps and get used to Azure. So it's one of the selling points. That's why they have named it Azure DevOps. Previously it was VSTS. So if I say VSTS, I will get a link. If I click on that link, previously it was VSTS, Visual Studio Team Services. They renamed it to Azure DevOps. They said VSTS is now Azure DevOps. So they rebranded it. Previously, I used to see VSTS logo here. It's no longer there. What they did, they're just revamping and pushing more and more people towards Azure. That's one of the biggest cloud platform you have out there, your Azure cloud platform. So that more and more people are adapting Azure. That's why you have the push wherein they have renamed your Visual Studio Team Services to Azure DevOps. That's one of the recent things that they did. This was not there 3 months back. 3 months back it was still VSTs. Now they have renamed it to Azure DevOps. That's a little bit of background. So coming back to our central versus global repository, we have seen this online as well just now. So that's one of the main differences. You have local repository sitting in your laptop when you are speaking about Git or Azure DevOps. When you are speaking about TFS, it is a live connection which you need to have to the main repository. There's nothing sitting locally. This is what is centralized source control. And what we are looking at is a distributed source control. This would be one of your interview questions, wherein they would be saying what is the difference between Git and any other source control system. You need to say that Git is distributed source control system, and any other thing is a centralized source control system. Then if he asks what is distributed, what do you mean by distributed, this is what you need to explain. That each developer who is associated with a distributed architecture, he would be having his own copy of local repository. Then using that copy is what he would be working with all his development cycle. Once he is done, he would go ahead and check in the code to the global or central repository. That's what happens when you are working with Git and distributed architecture. So just have that handy. That's one of your interview questions. So what is centralized source control? Oh, okay, let me repeat it. So essentially, when you are having the question would be something like this: what's the difference between Git and other repos, other repositories? What you need to say: Git is distributed. This first keyword. You need to say that Git is a distributed repository. What do you mean by distributed repository? He will ask you that for sure. So what do you mean by distributed repository? You need to remember this diagram which we saw. When we say distributed repository, each developer or each contributor onto the source control system, he would be having his own copy of the repository locally. Each contributor would be having his own copy of the repository locally. So whenever he is working on code, he would be working with the local repo. And once he wants to merge his changes with the central repo, he would be doing a push and he would merge it with the central repo. So what will he be working on? He will always be working on the local repository. And he would be merging changes with his global repository with the push command. So essentially, that's something. If you just say that he would be having his own local repository, then he would be merging the changes with the global repository. That's what he's looking for. So he's just looking if you understand that or not. So if you just use these terms and you say he has his own local repository and he would work with it and merge it with the global repository or centralized repository, that's what he wants to know. So once you say that, he would be happy. So just remember these statements: distributed architecture and local repository and central repository. You call this local repository, you call this central repository or main repository, anything. So just remember these terms, use these terms in your interviews. That's what he is working for. That's what he's looking for, your interviewer. So coming to your central source code management, when you look at central source code management, all of your code, the versions of your code are present in the central repo. And these are the versions which are pulled to your laptop. So these are two different software engineers working on a centralized repository. The centralized repository has multiple versions and they are both connected to the central repository by the internet. What happens in a decentralized or distributed repository? The centralized repository has V1, V2, V3, three versions. When you speak about distributed, your two engineers has V1, V2, V3 locally as well. How do they have locally? Because of local repo. They will get these versions locally and they will start working with them locally. That's why you have V1, V2, V3 here as well. Just to represent these things to you, because these are all internal. You will never be able to see local repository. It's all internal. Git maintains it internally. It's a black box. All you will understand, all you need to understand this is theoretically. So that's why it is important for you of what happens when you are speaking about local repo. You are having the versions which are present in the centralized repo, even in your local repository, inside the laptop of your software engineer. But that's not the case with centralized. The versions are present at the central repo. These guys don't have it. They connect to the repo and work with the versions. They can't have a local copy. That's what is distributed doing. They can have their own local copy and then they can start working with it. That's why Git is so famous, because of this distributed architecture. So it has a distributed architecture. What are the three stages which are present inside Git? Yeah, you said you're saying something? Anyone saying anything? Lakshmi Narayana, you said something? Yes. You when you speak about centralized, let me just stress on that. Once you pull the code locally, it's not a repository. You just pull the code. Is in TFS. Yeah, I am coming there. In TFS, you are pulling code locally. Start modifying code. Locally. and don't have internet connection, just remove your internet plug. In your TFS, you pulled code locally, start modifying code, start modifying at least 2 files, file 1 and file 2, and remove the internet connection. Then you click on the TFS node in your Visual Studio. What will it do? It will crash. And whatever modifications you did, you cannot compare these modifications with your centralized repository. Why? Because no internet connection is there and you don't have anything locally. You just have code. It's not the repo which is locally there. Just understand the difference. You don't have the repository in your local box. You just have code in your local box. And you cannot do anything with code unless and until you connect to your repository through internet. That's when you can say compare with the version, compare, you can do check-in, all of that is only possible then. You have code locally, you don't have a repository locally. In a distributed version control, you have a repository locally. I can do compare without internet connection. We'll do that. In Git, we will get the local we'll get the code locally, then remove the internet connection and do a compare. You can do a compare. You can look at the history. Remove the connection when you're doing with TFS. Do a compare. You can't compare because there is no internet connection. Check the history of a file. Go ahead and check it. If you are already having it, remove internet connection and then go ahead and say F1. Right click on that, and you will get view history. Do a view history. You cannot do view history because you are not having internet connection. Do the same with Git. Have a Git repo. Pull the code locally. Just the same stuff. Start modifying. Same your F1, F2. Do a remove your internet connection and do a compare. Compare will work fine. Do check history. It will work fine. Why it will work fine? Because of your local repository. You're not only pulling the code, you are pulling a repository locally. That would be one of the very basic differences between your TFS and your repo. You will clearly see a difference because of these things. You compare, you are checking history. You can also commit. Remove internet connection and commit here. Do a commit in TFS. Remove internet connection. You cannot commit. You need to have internet connection. Remove internet connection and do a commit. Here in Git, you can do a commit without internet connection. Where did you commit? You commit it to your local repository. You can do all this without connecting to the central repo. That's why it is distributed. That's the power of Git, which you don't get inside TFS. You just have code here, and you have to be connected to the central repo. Without connecting to the central repo, you cannot execute any of these commands. Here, without connecting to the central repo, I can execute all these commands. We'll see that. I cannot see that. I cannot show you that. If I remove internet connectivity, you can no longer see my screen because we are connected to the internet. I can't show you that, but do that. I'll tell you how to do that. You remove internet connectivity and do all these commands. You can still see that. I cannot do that because we are internet connected. I cannot live show it. If we are personally in a classroom kind of a thing, I could have showed that. But do these things in your Git repo. You can do all this. Got the difference? Or you need some more explanation? Lakshmi Narayana. Okay. So that would be one of your fundamental differences. So you just have code here in TFS. You don't have a repository. Here you have the entire repository, and you can play around with it with no connectivity with any internet. That's why Git is so famous, and that's why Microsoft bought it and integrated Git within its repositories. So if Microsoft bought it for millions of dollars and then integrated it Git here, then you can understand how powerful it is, and it will be having some features, and these are its features what we are looking at. What is the other thing we have? Just a second. Yeah. So you have three stages inside three stages in Git. You have committed, modified, and staged. There are multiple things. Once you start looking at code, that's when these things will make sense. We'll look at code. To look at code, we need to have a repository created, and then we can start working on it. For now, we will just look at it theoretically. Then we'll look at the practical aspect of it. So, what are the things when you say committed? Committed essentially means your code is committed to the local repository. That's what is the state wherein you did a commit. Your code is in the committed state. What is modified? Modified essentially is you did modifications to your code. Say file 1, you just went ahead and modified it. That's not the code what is present inside your repository. Your repository has 3 lines. Let us put it this way. The repository has in file 1 3 lines. You added one more line in file 1. So now your code which is present in your local box, that is file 1, is not the same as in your local repository. We'll look at all of this practically, but for now just understand theoretically. When we modify code, it's modified. The state what you see once you modify code is the modified state. So that's your modified state. Then you have staged. What is staged? When you are checking in code, you can take the code into a staging state. Because I have 5 files which are modified. I have 5 files which are modified. I do not want to check in all the 5 files. I only want to check in 3 files. So how can I do it? Whenever I have a scenario like this, then what you do is you will only modify 3 files. You only check in 3 files by taking it to staging area. What I do, I stage changes. You stage these 3 files, and then from the stage area, we'll see what the stage area is. From the staging area, you will check in the files. That's your staged state. These are the different states which your files go through. So these are very broad level categorization of the number of states in which your files go through. You have committed state, you have modified state, and you have a staged state. Why staged? Staged is these two are pretty common whenever you're working with any of the repository. If you have any exposure to any of the repository like TFS or .SSVN, you already know these two. Staged is something which is present in TFS as well. If you are familiar with TFS, it is present there as well. It is the same thing which is present here also in Git. You have staged state, wherein you stage the changes. So when you are working with Git internally, it has these 3 areas which it maintains. One is your repository area. This is where your actual code is sitting. This is all internal. You need not bother about it, and we cannot see these areas. We can only play around with these areas when we are working with Visual Studio. We don't see it, so it's all black box for me. So there is a Git repo area which is present. This is where my actual code sits inside the Git repo area. Working directory is the directory on which I am working. As a software engineer, I am working on a few changes for a feature. That's what is my working directory. So I will take the Git repo into my working directory. and I'll start working on it. That is what is my working directory. In my working directory, there are multiple modifications, just as what we just discussed. There are multiple modifications. There are 5 files which I modified, but I want to take only part of them. There is 3 files into the repository, into the central repository. What will I do? I'll stage them. I'll take these files into staging area. Whenever I do stage, I can right click on a file and do stage. They will be going into the staging area. I cannot see staging area, but when I say stage, they are actually internally moved to the staging area. So all of this is a black box. These areas, what you see on screen, is a black box. You will only work on it virtually using your Visual Studio, but you can't actually see it. But this is how theoretically Git maintains 3 areas. It has 3 areas which it maintains: your Git repo and your staging area and your working directory area. And once you are done with this, you have remote. We'll see that. What is remote? You have a local repo. You have a local repo, and then you have a remote repository. So you have a local repo and you have a remote repo. What do you do with these things, local repo and remote repo? You will be going ahead and working on the local copy, and you would be having a remote node. In the remote node, because other software engineers are also working on your repository, if AC2, your software engineer 2, created 3 branches, you would not be seeing that in your local repo. Why? Because your local repo was a previous print of your remote repository. If 3 branches are created now, you got this local repository at say 9 o'clock in the morning. You got the local repository. Once you got this at 10 o'clock, this guy created 3 new branches. Because you got it here at 9 a.m., you would not have known, your repository do not know that AC2 has created 3 new branches. How will you do that? How will you understand that? Once you look at the remote repo, there is a remote node. Once you look at the remote node, you cannot see these 3 branches inside the remote node. What will you do? You will do a sync. That is synchronize. You will do a sync. Once you do a sync, that's when your code is synchronized, and these 3 branches which he created at 10 o'clock are seen in your remote repository. We'll look at that practically, but now just understand there is another repository or another node which is called as remote node, wherein your remote code is being stored, and that is what is being shown inside your remote repository inside your GitHub. So that is what we will see. Okay, we want the staging area one more time, is it? Okay. So essentially, staging area is this guy. I have 5 files which I modified, and once I have modified 5 files, I don't want to check in all 5. I only want to check in 3 files. I don't want to check in all 5 files. What I'll do, I'll stage these 3 files. I can right click, stage. I can say right click and there will be a stage option. I'll do stage. What will that do? It will move my 3 files into staging area. Then I will check in from my staging area. So how many files will go inside a repository? 3 files. How can I modify code? How can I split these things like this? Without staging area, if I check in, all 5 files will go. I don't want to do that. So what I'll do, I'll stage 3 files. Then I'll check in code from the staging area. these three files. So that is what is staging, and that is what is staging area. You will go ahead and stage your changes. Then from the staging, you will go ahead and check in the code. Okay. Yeah, no problems. So that's about it. You have any questions? We are close to close. I'll leave the final 5 minutes or 10 minutes to discussion. Do you have any questions until what we discussed, or anything else which I can answer? Then we'll carry on with our discussion tomorrow. If you have any questions which needs to be addressed, you can just shoot.
Khan, this is, this is small clarification. So this is very similar to GitLab, right? Because I have somewhat experience on GitLab. So
yeah, this is absolutely similar. If you have experience with GitLab, it is similar to GitLab. That's
so
right.
all the commands and the way the work flows will be almost similar, right?
Almost similar. You will find that if you are anyway related to GitLab and Git, you're looking at the same flow.
All right, thanks.
Because in a class there would be multiple people, and everyone will not have the same idea. So I'll take them from basics. So if you already worked on GitLab, it is similar to it. You will feel that everything is common.
Yeah, thank you. I got it.
Yeah. So any other questions? If we have no questions, then we'll just close for the day, and we'll again meet tomorrow at the same time and carry on with our discussion.